Before there was time, before there was space, before there was anything, what was there? For decades, scientists believed the answer was simple: nothing. According to the traditional view, the universe began with the Big Bang, and asking what came before it was like asking what lies north of the North Pole. But in recent decades, physicists have begun questioning whether that answer is truly complete. Some of the greatest scientific minds have proposed radically different and deeply strange possibilities about what may have existed before our universe. According to our current understanding, around 13.8 billion years ago, all matter, energy, space, and time were compressed into an infinitely dense state called a singularity. Then came the Big Bang, an event that marked the rapid expansion of the universe. The evidence supporting this picture is overwhelming, including the cosmic microwave background radiation, the redshift of distant galaxies, and the abundance of light elements. However, there is one major problem. The equations of Einstein's general relativity break down at the singularity itself. They can describe the evolution of the universe after the Big Bang, but they cannot explain what happened at that first instant, much less what came before it. One of the most extraordinary ideas comes from physicist Sir Roger Penrose and is known as conformal cyclic cosmology. Penrose suggests that our Big Bang was not the beginning of everything, but rather the end of a previous universe. As a universe ages, stars burn out, black holes consume matter, and eventually even those black holes evaporate through Hawking radiation. In the end, all that remains is empty space filled with massless radiation. Penrose noticed that a universe in this final state mathematically resembles a universe at the moment of the Big Bang, because neither has a meaningful sense of scale. In his view, universes exist in an infinite chain where the death of one universe becomes the birth of another. He has even suggested that subtle patterns in the cosmic microwave background may be remnants from events in the previous universe, although many cosmologists remain skeptical of this evidence. Another possibility comes from Alan Guth and the theory of cosmic inflation. Inflation proposes that the universe experienced an incredibly rapid expansion during its earliest moments, stretching space faster than the speed of light. But some physicists, including Guth and André Linde, believe inflation never truly ends. In this model, known as eternal inflation, our universe is just one bubble that formed within an endlessly inflating cosmic background. Regions of this larger reality occasionally stop inflating and become their own universes, each with its own Big Bang, and possibly even different laws of physics. This means there could be an infinite number of universes constantly coming into existence. From this perspective, asking what happened before our Big Bang is like asking what happened before a single wave formed on an eternal ocean. Stephen Hawking and James Hartley proposed something even stranger with their no-boundary proposal. They argued that near the Big Bang, time behaved less like a flowing line and more like another dimension of space. Using the concept of imaginary time, they suggested the universe does not have a sharp beginning. Instead, it is smooth and finite, similar to the surface of a sphere. Asking what came before the Big Bang becomes meaningless in the same way that asking what lies south of the South Pole has no answer. There is no edge of reality. Rather, the concept of before simply stops applying. In this view, time curves smoothly into existence without a distinct starting point. Physicist Lee Smolin introduced another remarkable possibility called cosmological natural selection. He proposed that every black hole may give birth to a new universe on the other side, each with slightly different physical constants. Universes that are particularly good at producing black holes would create more offspring universes. Over unimaginable timescales, this process would resemble natural selection, except instead of organisms evolving, entire universes would evolve. Smolin's theory attempts to explain why our universe appears to have precisely the right conditions for stars, chemistry, and life. His answer is that these same conditions are also highly efficient at creating black holes, allowing universes like ours to reproduce more successfully. The difficult truth is that none of these ideas have been proven. Penrose's cyclic universes, Guth's eternal inflation, Hawking's no-boundary proposal, and Smolin's evolving universes are all mathematically plausible, yet direct evidence remains elusive. Some of these theories may never be testable, because the clues we need could lie forever beyond our observable universe. In many ways, humanity is trying to reconstruct the story of reality itself, using only the faint afterglow left behind by an event that happened at the dawn of existence. Perhaps the most humbling part of this mystery is that we have mapped trillions of galaxies, detected the collisions of black holes billions of light years away, and even captured images of a black hole's event horizon. Yet the question of what, if anything, existed before the Big Bang remains unanswered. Maybe there was nothing. Maybe there were countless universes before ours. Or perhaps the question itself is fundamentally flawed. The truth is that nobody knows for sure, not even the smartest physicists on Earth.